I've been in Penn State archives for 6 hours, going through energy reports, and I need to tell you what I found. What I found in a U.S. Department of Energy field report from 1995 changes everything you think you know about hot water. 2,502 kilowatt-hours. That number sat on the page like a threat. It looked inflated. It looked like marketing. It was not. The report used monitored field data compiled by the Florida Solar Energy Center. It was technical, dry, easy to ignore, and almost nobody remembers it exists. 2,502 kilowatt-hours. I kept turning pages. Pennsylvania State University showed 1,758 kilowatt-hours saved per year. Austin showed 2,813. Long Island showed 1,779. Florida systems covered up to 75% of household hot water demand. Different climates, different roofs, different installers, same sun, same water. Same result. 2,502 kilowatt-hours. That is what the average residential solar water heater displaced each year in electricity. Not in a lab, in houses, real houses, the kind with laundry, dishes, baths, and teenagers. And the machine doing it was almost insulting in its simplicity. A dark surface, a glazed cover, a storage tank, a few pipes. That was enough. Then the older paper trails started to line up. Clarence Kemp patented the Climax solar water heater in 1891. By 1897, Pasadena already had solar heaters on 30% of its homes. One manufacturer sold over 10,000 units by the late 1920s. By 1941, at least 60,000 solar heaters were installed in California alone. That knowledge never disappeared. It was written out of the manual. It was waiting. I pulled another file, then another. An Oregon State design from 1986 used a glazed box, a reused tank, and common framing lumber. Modern builders often replace the old absorber with a thin aluminum sheet. Cleaner, faster, cheaper, same principle. The part that should shake you is this. The expensive miracle was never the point. The point was ordinary material arranged correctly. I found a photo from 1979 next. White House roof. Glass, aluminum, and stainless steel panels. Jimmy Carter standing near them like he was trying to point at a road the country still had time to take. 7 years later they were gone. Tax credits were ending. Utility logic was back in charge. The billable version won. And once you see the sequence, you cannot unsee it. This was not fringe science. It was patented, sold, monitored, improved, and field-tested for decades. Then the country was trained to think hot water must arrive through a burner, an element, and a monthly statement. Nobody told you. Not your builder, not your contractor, not the man who sold you the replacement tank. The California numbers make the loss harder to excuse. By 1900, more than 1,600 Climax systems were already installed. William J. Bailey later split the collector from the storage tank. His day and night system sold over 4,000 units by the end of World War I. Then wartime copper controls hit. Cheap fuel took over. Builder habits hardened. The market did not die because the sun stopped working. It died because centralized energy and factory equipment scaled faster inside the post-war economy. Here's what the evidence shows, and here's why nobody was supposed to find it. You are looking at a simple arrangement, a sheet of metal, a pane of glazing, ordinary plumbing, sunlight turned into stored heat. One measured program tracked annual savings of 2,502 kilowatt-hours. Another showed families covering over half their hot water demand with the sun before the meter did anything. And yes, this works even if your house was built 50 years ago. Stay with me. Because what I found in a Pennsylvania archive uses the same physics the Romans used to heat baths 2,000 years ago. The science is embarrassingly simple. The U.S. Department of Energy reported average savings of 2,502 kilowatt-hours each year. The field data came from the Florida Solar Energy Center. The measured solar fraction usually ran from 35 to 57%. Florida reached 75%. That means the sun handled over half the job before the utility touched it. A glazed collector works like your black shirt in winter. Sunlight passes through the clear cover. The dark surface underneath absorbs it. The heat stays trapped long enough to warm water instead of the wind. The storage tank then does what a cast iron skillet does after the burner shuts off. It holds heat. It releases it slowly. It stays useful. The Department of Energy also notes a simple sighting rule. If the collector faces within 30 degrees of true south, it still receives about 90% of optimal winter solar gain. That is not a narrow target. That is a forgiving one. In practical terms, a small collector can push water past 120 degrees Fahrenheit on a bright day. If you use a tiny circulator drawing 18 to 25 watts, the heat moved can equal 1,100 to 1,600 watts. That is 61 to 88 units of heat for every 1 unit of electrical input versus 1 for a resistance heater. In thermal terms, the coefficient of performance is absurd. Pacific Northwest National Laboratory describes passive integrated collector storage units as self-contained solar tanks holding 30 to 50 gallons. No pump, no controller, no software update. Keep plumbing short, keep shading low. Keep the collector honest. That is why old farm families understood this so quickly. It behaves like a spring house roof or a south barn wall. It rewards placement first, machinery second. That gap represents a massive market in tanks, burners, contracts, and service every year. And that is why you have never heard of this. I saw the living proof in East Hempfield Township just west of Lancaster. It was late October. The air sat around 43 degrees. The lane was wet. I could hear buggy wheels on crushed stone. I could hear geese. I could hear a hand pump. I could not hear a compressor, a condenser fan, or any mechanical hum. Reuben met me by a washhouse door. He was direct, calm, slightly amused that I was writing everything down. Light was hitting the south wall hard. Beside it sat a dark collector box and a preheat tank line running toward the house. He tapped the box with one knuckle and said, "My grandfather said the sun does the first heating. The stove only finishes the argument." Then he lifted the lid and told me to touch the pipe. It was warm before noon. He said the habit went back 4 generations in his family. He said the old people cared about where a wall faced before they cared about what color it was. He said families from Canton Bern, Alsace, and the Palatinate brought that attention with them. The phrasing was plain. The engineering was not. The Amish didn't read this in a textbook. They figured it out the old way. They paid attention to what the earth and the season were already doing. The record backs the habit. The Pennsylvania Historical and Museum Commission's Lancaster Plain study preserved a useful detail. It noted a Drew Moore Township tobacco barn, dated about 1879. The barn was banked. It faced south. It used a roof ridge ventilator. Penn State historian Sally McMurray traced those building forms to Pennsylvania German settlement patterns and Swiss and German cultural influence. The language changes. The hardware changes. The habit does not. Go back farther and the pattern gets louder. In the Roman world, Bath buildings used broad south-facing windows, and historian J.W. Ring documented how Roman glass admitted useful solar gain into heated rooms. In Chaco Canyon, Pueblo Bonito ran on an east-west axis, so its long wall faced south, pulling winter sun into thick masonry. Different empire. Different continent, same answer. In Rome, sunlight entered through glass and warmed stone that released heat after sunset. In Chaco, adobe and masonry performed the same slow storage job with different material. Nobody held a patent. Nobody filed a rebate form. They watched light, wall thickness, and season. Every civilization that mastered winter cold arrived at the same answer independently. The Amish never forgot. They carried it from Canton Bern and the Palatinate to Pennsylvania 300 years ago. They kept building it because it worked. They never needed anyone's permission to do what made sense. The modern erasure starts in 1938. That was the year Owens Corning Fiberglass became a standalone company, selling thick fibrous insulation into the exploding housing market. A thin sun-facing heater made from metal, glass, and a storage tank threatened more than one product line. It threatened furnace sales, it threatened water heater sales, it threatened monthly fuel. Owens Corning sales reached $78,765,000 by 1950. By the end of the 1950s, annual revenues had topped $211 million. The mechanism was quieter than a ban. In 1945, Penn State engineer Everett Schumann proposed standardized measures of resistance to heat transfer, the basis of the R-value system. Useful, necessary, incomplete. Once heat control was reduced to thick material tables, thin reflective layers, and solar thermal collectors became awkward outsiders. Mortgage rules and trade practice then favored equipment that could be boxed, financed, priced, and inspected the same way everywhere. What was hard to rate became hard to approve. What was hard to approve became easy to ignore. The allies were real. General Electric sold electric water heaters and owned NBC. The Federal Housing Administration normalized conventional mechanical systems inside the mortgage economy. Owens Corning sold insulation into those same houses. Utility advertisers bought space. Appliance makers bought space. Media sold attention. Government sold standardization. Industry sold the hardware to fill the standardized shell. Different departments. Same direction of money. Then the cultural wipeout finished the job. Trade schools taught replacement, not orientation. Builders learned tonnage, not sun angle. Homeowners learned monthly payment, not thermal storage. An entire field of knowledge disappeared from architecture schools, building codes, and contractor training. Not because it failed, because it was less profitable than tanks, ducts, burners, and replacement cycles. You can watch the continuation in public. Yale Climate Connections traced the White House solar water panels. They went up in 1979. They survived 7 years. They were removed in 1986. Reagan Press Secretary Dale Petroski defended the move on cost grounds. The Carter-era homeowner tax credits for solar water heaters had already ended on December 31, 1985. Same timing, same direction, same lesson, and the current version is even easier to trace. Influence Map reported that since 2019, the American Gas Association and the National Propane Gas Association coordinated campaigns against building electrification. Open Secrets reported that the American Gas Association spent $1.36 million on federal lobbying in 2023 alone. Different target. Same motive. Every gallon heated by the sun is fuel that never gets burned. The U.S. HVAC systems market in America was valued at $27.85 billion in 2022. Every passive heater installed is a tank, service call, warranty plan, and fuel bill that never gets sold. Listen to the sales language around you. They tell you efficiency starts with equipment. They tell you comfort lives in a catalog. They tell you every problem needs a larger burner, a smarter thermostat, or a newer tank. They never start with orientation. They never start with storage. They never start with free heat already falling on your roof. Not because it failed, because a passive system closes the sale before the salesman arrives. Think about what that means in your own house. Incoming municipal water often reaches you at 48 to 58 degrees. Your heater must drag every gallon from there to usable temperature. A preheat collector cuts that lift before any paid fuel enters the picture. 10 gallons, 20 gallons, 40 gallons. Every shower starts cheaper. Every load of laundry starts warmer. Every sink full of dishes asks less from the grid or the gas line. That is why this matters. The savings are not mystical. They are arithmetic. Lower starting temperature difference means less purchased energy. Less purchased energy means less leverage over you, month after month, year after year, without permission. Now, if you already own a house and you're thinking this only applies to people with land, stay with me. Because this next part is specifically for you. You don't need to buy equipment. You need a south wall, a patch of sun, and one weekend. If you want the simplest version, build the collector first. Make the box 76 inches long, 36 inches wide, and 10 inches deep from 2x4 lumber and half-inch exterior plywood. Line the back and sides with 1-inch foil-faced polyisocyanurate. Set the base 16 to 24 inches above grade on pavers or blocks. Fasten a 26-gauge aluminum sheet across the upper cradle, then paint that face flat black. Over it, set one 34 by 76 inch pane of tempered patio glass or twin-wall polycarbonate. Behind the absorber, run 50 to 60 feet of half-inch PEX AL-PEX or soft copper in a tight serpentine. Feed that loop into a 30 to 50 gallon preheat tank. Use 3/4 inch Schedule 40 CPVC or insulated PEX for supply and return lines. Keep the total run under 25 feet if you can. Set the collector at a 30-degree tilt and face it within 30 degrees of true south. Add a brass anti-scald mixing valve set near 120 degrees before the water reaches the tap. The costs are low enough to offend people. The aluminum sheet runs $22 to $29. The polyiso board runs $32 to $48. A salvaged patio glass panel runs $55 to $110. The PEX or copper loop runs $34 to $62. Fittings, high-temp silicone, pipe insulation, and flat black paint add another $38 to $74. The mixing valve runs $38 to $74. Total cost lands between $219 and $397 if you salvage well. The startup is simple. Fill the preheat tank first. Purge the air. Open the bypass slowly. Watch the collector reach temperature before you trust your gauges. By the second clear day, the routine becomes obvious. Cold water enters low. Warm water rises. Your main heater finishes less work because the sun already did the first part. There are two ways to place it. Ground mount is simplest. Wall mount works if the wall gets clean sun from 9 a.m. to 3 p.m. Roof mount works too, but Oregon State's old plan gave the right warning. Consult structure first. Water is heavy. Glass is heavy. A collector full of both does not care about optimism. The anti-scald mixing valve is not optional. A plain bypass causes dangerous 140-degree water at the tap. There is one more warning. Freeze exposure matters. If your winter routinely drops far below 32 degrees Fahrenheit, use a drain-back design, seasonal bypass, or an indirect loop. Bare water in exposed lines will punish lazy plumbing. Use closed-cell pipe insulation. Seal every penetration. Protect the weak points. On a 41-degree February day with clear sun, this setup can preheat 52-degree supply water. By late afternoon, it can reach 94 to 108 degrees. On a bright July day, it can climb higher. Maintenance is simple. Wash the glazing once a season. Check insulation once a year. Replace weather seals every 8 to 12 years. Flush sediment from the preheat tank when you flush the main tank. Your conventional water heater costs $900 to $1,900 to install. It runs about $32 per month. It lasts 8 to 12 years before it ends up in a landfill. This costs $219 to $397 total. It lasts 15 to 20 years. Your choice. Everything I've covered across this channel is in one place. Root cellar summer cooling. Lime wash walls against mold. Gravity-fed spring water. Step by step, season by season, room by room, in the order the families actually use it. I haven't named it yet. Link is in the description, but stay here, because what Ruben built is the part nobody is talking about yet. If you believe real knowledge has been quietly pushed aside to protect someone else's profit, you already know what to do. Hit subscribe. Not for me, for what comes next, because this is not a channel. This is a quiet movement of people who have decided they're done being sold what they already own. I want to hear from you. Drop your state, your monthly water heating bill, or the oldest hot water trick your family still remembers in the comments. I read every single one, and your answers decide what we cover next. Next week, I'm going to show you what a 1946 Penn State document reveals about cooling food, milk, and meat without compressors. The technique uses nothing but stone, moving water, and shade. And the Pennsylvania farm record proves earlier builders knew how to hold 55-degree temperatures through summer heat. You're not going to want to miss that one.